Okay, so now that we have defined our configurations and our muscles or the controllers for the different joints, we're ready to control the robot, right? So we have this block in the Zacro URDF to define the control for the joints, the muscles of the robot, okay? That's in the description. And then I have a new package, Gazebo, just for everything about launching and displaying the robot. It's good to organize things in different packages. And in this package, I have this launcher that first of all will find the URDF or the description of the robot in the corresponding description package. There I have this argument where I say what kind of world we're going to launch, and we're going to use the empty world for now. So here's just more about those two, the URDF and the world. Here's just to tell Gazebo where to look for resources, where to find the empty world in this particular case. Here we launch Gazebo itself and we tell it which world we want to launch. And here we launch a special launcher, another launcher that will call RViz, and we'll tell it which URDF to use so we can visualize the robot in RViz. Here we are telling Gazebo where to spawn a robot, and we're telling it look at the robot description to know what our robot looks like and spawn it at this position. So here's the important thing. We're going to load our controllers, and we start with the joint state broadcaster. So this is our feedback, and it's going to be in the controller manager package. So the controller manager will take care of it, right? Remember, there's a controller manager, and we have the joint state broadcaster is the feedback node, or the one that will tell us all about our joints. Then we have the all steer position controller, also controlled by the controller manager. This is about the steering. Remember, it's here. It's a position controller that will help us steer the robot. And then we have the all drive velocity controller. Okay, this is the one that will help us move our wheels by sending velocity commands to them. And we can't just launch those right away. We need to wait until a robot has been spawned in the simulation. So we have this kind of delayers, let's call them, where we're gonna do something after something has happened. Okay, so in this particular case, we are going to wait for the spawn entity to be done before we can launch the state broadcaster. So what is this spawn entity? Well, it's the one that will put our robot in the simulation. Okay, so once our robot has been launched, then we can load the state broadcaster. And then once the state broadcaster is ready, then we're gonna load the steer controller and the drive controller. So it's like a chain of events. Spawn the robot first, then load the state broadcaster. Once the state broadcasters are ready, load the steer and drive controllers. Okay, we need to make sure that happens in that order, otherwise things may fail. And then we just put all of these things together into the launch description. So let's try it. So we go to our ROS workspace, we source it, right? Always source it. I have already previously built the whole workspace, so I don't have to do it again. And then I go to the Gazebo package and I launch not TP2, TP1. And then this opens RViz and everything that we need. But let's have a look at the output here. So you see here, we can see that all of the controllers for the different joints have been loaded. So I'm ready to send position and velocity commands. Here we see that all of these plugins are ready. Here we see that we loaded the joint state broadcaster and it's configured by the YAML file. We loaded all of the two steer and drive controllers, and they're configured as well. Everything is ready. So everything is ready, and we are going to see it in action. So now what I need to do, just first, let's confirm. So ROS2 node list. and we can see that there's a node for the drive and the steer controller, the control managers there. The interface that will connect everything between ROS2 and Gazebo is there, and the state broadcaster is there. Robot State Publisher is the one that publishes the robot information, the TF3. Don't worry, we're going to see more about that later. And then topic list. We have a way to send commands. This is velocity commands, position commands, and that's all we care about for now. So all of these are just little ROS2 commands that you should learn. But again, this is not a ROS course, so I'm just going to mention them, and you can learn them from the official tutorials. Okay, we're ready. So let's organize these windows a little bit. I'm not very good at organizing windows. That should do. Okay, and let's discover how we can send. We're going to send in a velocity command just to test that we can move the robot. So we're going to use again ROS2 command line tools. So ROS2 topic publish some information, and we already saw that we have this all drive velocity controller commands topic, and is a float 64 multi-array. So is an array of floats, and we can use the structure. We need to discover the structure. It started with the layout thing. Okay, there it is. And then now in the data field, we can send the velocity. So we have 6 of them. So we're gonna just send the same to all of them. So 1.5 meters per second to 6 times. Put it there 6 times for 6 wheels. And when we press enter, you see the robot starts moving. We can see it in Arvis. You see that all 6 wheels are spinning, and you can also see it in Gazebo. Our robot is moving, so our control is working. Our muscles are ready. We have now a robot that is more than just visuals, but or skeleton, if you want. We have a skeleton and we have muscles. We can move a robot. So in the next section, we're gonna learn how we can use actual code. We're gonna study a very simple Python script to move the robot, making turn. Right now we just added velocities to make it go forward, but with code, we're gonna see how we can make it turn, stop, etc. So see you in the next lesson.